Today's presentation is going to reinforce what was presented in the Landforms vocabulary matching that you did last week. So I gave you a list of all these landforms and I described them to you. Then I gave you a set of pictures and I said, hey, which ones of these matches these descriptions? And that was your way to identify them. You will have a quiz later on this week where you have to do the same thing, where you have to identify and match the pictures of a landform to their term and or their description. But today's presentation is more of an extension. It's some extra stuff beyond just the definition of what a landform is. First of all, this is something that wasn't introduced to you before in the vocabulary, this idea of an erosional versus a depositional landform. Now, erosion is when you take stuff and you move it somewhere else. Well, then of course the land's going to look different. So an erosional landform is when the land has a certain shape because sediments were taken away and now the land looks different. We also know that those sediments, as they get moved away, they'll go somewhere else and sometimes they get dropped. Well, a depositional landform is a way or a shape of the land because sediments were brought there and then dropped. So now the land looks different because there's a big pile of stuff there. We'll start off with underground landforms, things we don't see so much on the surface. First of all, no big mystery here what a cave is. It's a natural hollow space under the surface of the earth. Key word here, it has to be natural. And most caves are what we call solutional caves, not all. And we'll look at some other examples later, but a solutional cave is one that is formed when water moving through the ground dissolves the rock and moves the rock away, and you're left with an open space. It basically happens like this. It rains, and we're very well aware what happens to this water. It moves down here through the ground because all ground is at least a little bit porous, and there's actually going to be at least a little bit of water going into the ground. Now, we also know that water is the #1 agent of weathering, of breaking things into smaller pieces. So water will do this. It will eat away at the rock and break it into smaller pieces, and then eventually it gets eroded. It keeps going down or it gets moved out, when the water flows out of the ground, and what you're left with is an open space, typically filled with water. And this is very much true. This is especially true if you have rock that reacts with water to form a weak acid. Because we saw from our weathering properties lab that acid will eat away some types of rock. So then the water table goes down. Or let's say we go to a cooler time of the earth where there's more water now trapped in glaciers than there was in the warm period. So the water table goes down, and that area where the water had dissolved the rock is now just a big open space. That is a solutional cave. It was a cave, a natural hollow space under the ground that was formed when water weathered away the rock and left an empty space behind. Now, keep in mind, we know that the ground isn't the same everywhere, that there's different rock under the ground at different places. You know that when we did our weathering experiments that some rocks will break down easier than others. And we also know that water is the #1 thing that does this whole weathering and erosion. So these three sets of circumstances are going to help to determine whether or not you have caves in a certain location. Different places get different amounts of rain. So all of these things together are going to help us predict as to where we might find a cave. Now, before we move on, I want you to think about what's a rock that will break down or weather easier. We saw in our last unit that limestone especially breaks down pretty easy. Where is a place where we get lots of water, especially a lot of precipitation? Well, that's pretty much back in the east. So if we know a place that has a lot of limestone, and especially that it's back east, it's probably a place where we're bound to find some caves. So where are caves found? Here's a map of the concentration of caves. Now, first thing that should jump out at you, there are a lot fewer caves out here in the West. And that's because of two reasons. One, the ground isn't made the ground is not made up of as much limestone, and limestone is that rock that will dissolve when water moves through it. Plus, there just isn't as much rain in the West. So we come back east, and we got a couple places here. Right in here, which is primarily Missouri, northern Arkansas, but definitely Missouri, and Kentucky, Tennessee especially, both have lots of caves. There's also a little higher concentration here in Texas. So why so many caves in these particular areas? Now, before we answer our question as to where we find caves a lot of, keep in mind there are caves in pretty much all 50 states. It's just a question of where are they found more. Tennessee, Kentucky, and Missouri are the states that we're going to say have the most caves. As a matter of fact, those three states kind of have a running argument as to which one of them should be called the cave state, because Missouri, Kentucky, and Tennessee kind of all argue that, hey, we have the most caves. And it's not an easy question or score to settle. But those are the three states that I want you to remember that have a lot of caves. So why? Well, all three of those states have a lot of limestone under the ground. So that's that rock that will get dissolved by water. And they're all back east. They're all places where you get a lot of precipitation. So we got this ground where water will go into the ground easily, and there's a lot of water raining down, and that rock down there is easily dissolved. That's the perfect recipe for a cave. Now, Florida, if you look on this map, Florida doesn't seem to have many caves, but Florida is almost all limestone, and we know Florida has a lot of precipitation, and we know that water goes into the ground. The difference with Florida is that most of the caves in Florida are filled with water because the water table is so high. As a matter of fact, cave diving is a very popular activity in Florida because all that limestone gets eaten away. And so they have a natural hollow space under the ground. They have caves, but because of the water table is so high and because it rains so much, their caves are typically filled with water. Now in Georgia, we have caves. We have over 500 documented caves in our state. And as you can see from the map, most of the caves in our state are found up here in the northwestern part of the state. The reason for that is that there's different rock up there. The whole state of Georgia gets a fair amount of rain, but the rock type in the northwestern part of the state is the right type of rock to be dissolved easily by water. In the south part of the state, it's not very rocky at all. The land is flat, there's not much rock, it's mostly clay, even some sand, and the water table is real high, so they don't have a lot of caves in South Georgia. Now, there's a very famous cave up in Walker County that is over 12 miles long, and it is Georgia's longest, deepest cave. Now, we don't have many caves here in Atlanta, and the reason is we're sitting up pretty high, and we're sitting on this nice bed of granite, which is not easily dissolved by water. So when it rains on top of granite, the rain doesn't go in very easily, and the minerals that make up granite don't dissolve in water, so therefore you don't have as many caves in places where you have a lot of granite in the ground. Now there are some very notable Georgia caves. There are actually some very famous Georgia caves among spelunkers. Those are people that go in and explore caves. Fantastic Pit in Ellison's Cave, that's that one that's 12 miles long, goes straight down for 586 feet. It's literally like an elevator shaft going straight down. You and I can't go visit Ellison's Cave. You have to be a professional spelunker. You have to be a professional or very serious cave explorer to be able to go and enter this cave, because as you can see from the picture over here, it takes some real serious rappelling and rope work to go down the height of an almost 60-story building down. Ruby Falls is another very famous cave. It's up near Chattanooga, Tennessee, but it's famous because it has a waterfall inside. And this is a great cave to show you how water can actually carve out a cave. You can see the water coming in, and you know what water does to certain types of rock. There you go. That's why you have a cave there, and the water is still moving through the cave, making it bigger. Some other notable caves. First of all, Carlsbad Caverns, which is in eastern New Mexico, kind of close to the Texas border. You can see on the map here. This is our largest and most famous cave in our country. It is in an area that's pretty dry now, but it was underwater at one time. So the water's not there anymore, but it did its work, and now that it's dry, you can explore this cave. It has miles and miles and miles of passages and just huge amounts of cave formations. The big room, which is this right here, which is very hard to take a picture of. The volume of that big room is larger than Mercedes-Benz Stadium. It's larger than your typical domed stadium. Now, it's not all uniform, but that one chamber, that one room is the largest underground cavern, largest underground room in the world, at least that we know of. Mammoth Cave in Kentucky is another famous cave because it is one of the longest caves in the world, and it has not been fully explored. It has 367 miles of known passageways, and you can go into Mammoth Cave, many different locations, and you can take tours through there. You have to be really serious and go with professionals if you want to get really deep into the cave, because it hasn't even been entirely mapped out yet. In Australia and New Zealand, they have some very famous caves that are filled with what they call glowworms. Caves are a very unique environment. Not all animals can live in the complete darkness, but these caves in Australia and New Zealand have these insects, these worms actually, that adhere to the ceiling of the caves, and they make out this almost like a spider's web, and they glow, and it attracts bugs that have flown into the cave, and they get stuck in there like they would in a spider's web, and that's how they eat. So very famous, very well known, only happens a couple places in the world. Stalagmites and stalactites. These are these formations that we get in a cave when the water moves through. Now we know the water is coming down, and as the water moves through here, it has picked up some minerals. It's dissolving. Then it falls into this spot here, and it drips through that opening. Well, and when it drips, it doesn't take all of its minerals with it. So what you wind up with is a pile of minerals right here. When the water starts to drip into the cavern, it leaves some of the minerals behind. And when it hits the floor, you wind up with a little pile of minerals. And these are stalagmites and stalactites. Here's a good example of how these things form. You can see here, this is the pile of minerals. Water was coming down from the surface, and you can see it is getting ready to drop right there. And even though the water looks fairly clear, it's got minerals in it. And as it was sliding over this formation, it left some of the minerals behind. And so this formation is actually getting a little bit bigger, because every time the water drops, it leaves a little bit of minerals behind. Here you can see the pile of minerals that is starting to build up from this over here, dripping. This spot right here was directly under this over here, and you can see the splattering of the water, and you can also see how you're starting to get a pile of minerals. If this continues, what you're going to have 1,000 years, a couple hundred years, you'll have a pile of minerals here that'll match the pile of minerals on the ceiling. Those are stalagmites and stalactites. Stalactites hold tight to the ceiling, so this is a stalactite. Stalagmites are one that might eventually reach the ceiling, so they're the ones on the bottom. So here we've got a stalactite that has been growing this way. We've got a stalagmite that's been growing this way, and they're going to keep growing so long as there's water flowing into this cave, and eventually they will meet. When they meet, they're called a cave column. And these are formed when a stalagmite and a stalactite end up connecting. Now, flowstone is a little bit different. Flowstone is when we have a lot more water coming into the cave. It's flowing water, hence the word flowstone. It's not one drip at a time. So these formations tend to look a lot bigger, and they kind of look like chocolate fountains. Have you ever seen one of those? Excuse me. So this was a lot of water that was flowing into the cave at one time, so it left a big pile of minerals behind. Now, sinkholes. Sinkholes and caves are kind of related. A sinkhole is when you get the ground on the surface that collapses due to what the groundwater did below. It can look something like that. It can look something like that. It can even look something like that. These are all cases where something happened to the ground underneath the surface. And you had a big hole, a big opening, eventually it gave way, and you have what's called a sinkhole. Here's how they happen. So we know the rock underground's got open spaces, and it rains, and water gets into those cracks. Well, the water's going to eat away at the rock. So eventually you wind up with a kind of a big open space, just like we get when we have a cave. But if the water level goes down, like they're taking groundwater out from wells, or we just have a drought, or it's just a natural lowering of the water table, then we have this empty cavity. We got open space here. Well, if this up here has gotten pretty thin, it might not have enough weight to support itself, and it will fall in. That's what a sinkhole is when the ground on the surface collapses because too much of the ground underneath has been weathered and eroded. Here's a good example of how a sinkhole would happen. You can still see the water there. Here's the opening. You can see where it collapsed right here. And you can see here where there's still the water down here. This was the big open space under the ground. And it basically got too thin. Water was still running through the ground. And this part here got too thin so that it collapsed and fell in to the water. This is Devil's Den. This is in northern Florida. Obviously, you can see you can walk down there in the sinkhole, which still has water in it, and swim around because it is still spring fed. Now, where are sinkholes most common? Florida has more sinkholes than any other state by far. It's a big problem in Florida. They're also common in Texas, Alabama, Missouri. You see all these places that have a fair amount of limestone and a lot of precipitation. Notice no Arizona, no California, no Nevada, not places where it's dry. So why does Florida have so many sinkholes? Well, they get a lot of rain, and the ground is limestone, which is the rock that is easily dissolved. So if the rock's easily dissolved, it's a lot more likely to collapse on itself. Now, we don't get sinkholes here in Atlanta because, once again, we're on granite, and granite just doesn't get dissolved by water, so it's not going to collapse on itself. But we do have some artificial sinkholes. You will hear about sinkholes on the news sometime, and there's a kind of a difference between man-made ones and natural ones, but the process by which they form is the same. So underneath the ground here, we had a water pipe, and the water pipe leaked, and this water got into our soil, and it basically broke down the soil and moved it away so there wasn't enough soil ground there left anymore, and our parking lot or our road, whatever, collapsed into the open cavity. A lot of times these sinkholes, you don't know they're going to happen because you don't know that the water pipe is leaking under the ground until the parking lot or the road or the yard or the house just collapses. Now, how deep are these sinkholes? Some of them can be just a few feet deep. You can walk to the bottom of them. But some of them can be up to 1,000 feet deep. Zacatón in Mexico is the world's deepest, and it's over 1,000 feet. They don't even know exactly how far down it goes because it is so deep. The Great Blue Hole, which is a sinkhole that is off the coast of Belize, is about 500 feet deep and 300 feet across. Now, it was formed when there was more water locked in glaciers during the last ice age. Well, the glaciers have melted after the last ice age and ocean levels have risen, so now the Great Blue Hole is back underwater again. It's not going to get any bigger, but it's still really cool that you have a sinkhole that is now in the ocean. The two at the bottom, you can see that 330, 200 feet deep. These occurred in Guatemala in 2010 and 2007, and you can see they're in cities because you never know what the water is doing under the ground. They could happen in the country, they could happen in the city, and if your house happened to be right there, which there was a case where they had some buildings and such that were over the sinkholes, your building winds up at the bottom of the sinkhole. Hopefully you weren't in it at the time. How big are they? Well, here's one that was about 900 feet wide. That's kind of the exception. Most sinkholes are only about 10 feet across before they collapse on themselves, but they could be pretty good size. There are cases where, you lose 3, 4, 5, 6, 7 houses in a neighborhood because the sinkhole ends up being so wide. How fast do they happen? They can happen almost instantly, like just a straight landslide type collapse, or they can start to slowly sink over hours, even days. In Florida, they'll have news reports where they start to see the sinkhole happening, and people just have to get out of their houses and wait and see, is it going to collapse under their house, or how big the sinkhole is going to get. Now, sometimes all the land doesn't collapse on itself. It can just move down together. That's a term called land subsidence, basically where all of the land goes down together. And this typically happens when you take water out of the ground, because the water in the ground takes up space. So especially if you have very sandy soils, the sandy soils kind of float up a little higher because there's a bunch of water in between the sand. Well, if you take the water out, then the sand kind of starts to compact on itself and the land levels go down. Notice in 1965, that's where the land was. 2013, it's down here. The land has gone down 7 feet in 50 years. 1925, you can see that's how high the land, that was the elevation of the land. And in 1977, the land was down here. Now, land subsidence mostly happens where people are taking a lot of water out of the ground. Very typically in farming areas, especially in dry farming areas like in California, where they need the groundwater to grow the crops, but it doesn't rain enough. So they start taking all this water out of the ground, and the ground starts to sink. Now, New Orleans has famously taken water out of the ground to make it drier so that they had more space to live. In this part of the city over here especially, there were a lot of wetlands, a lot of swamps. Well, they took all of the water out of the swamps so that they could make the land dry and build houses and people could live there. Problem is, over time, with all the extra weight of all that buildings and people on top, and then no water in the soil to help it float up higher, the land started to sink and it started to compress, and they had a lot of land subsidence. This is why New Orleans now is so much below sea level. It wasn't always the case that it was below sea level, but the land in New Orleans has sunk because they took the water out of the land. One, they took it out of the land to make it dry land to build on, and two, I think 150, 200 years ago, people took water out of the ground via wells for their drinking water. So either way, the water came out of the ground, and the ground has now sunk. Atlanta. Let's talk about our land subsidence here in Atlanta. We don't have any for two reasons. One, we don't take water out of the ground like they do other places because we have plenty of rivers to get our water from. We don't use wells and we don't pump water out of the ground. Two, we're on top of granite. There isn't a whole lot of water in granite, and granite's pretty tough that even if you took all of the water out of granite, it's not going to sink on itself. So we don't have this problem here. Primarily places like New Orleans and in the farming areas of California.